Good afternoon, ladies and gentlemen. I'm very happy to welcome you today to this webinar with an extremely exciting and relevant topic. I'm glad you made the time to participate to our event. My name is Andrea Hoffmann. I'm a partner at Capco Zurich. I met Jay over a couple of years ago during an event of his Geneva WealthTech Hub. I was not only impressed by his personality, but also what he has put into place. It was an excellent event with interesting speakers and lots of learnings for me. Therefore, I'm honored that Capco, a global management technology consultancy focusing on financial services, can host this webinar together with you, Jay, and the team. With Mohanty, Miguel, Neil, and Apri, we have impressive and knowledgeable speakers. I'm looking forward to their sharing of thoughts and experience. Maybe, Florence, you can go to the next slide, please. Florence, do you hear me? Can you go to the next slide, please?
Yes.
So maybe it's just me. I still see the title slide, and I quickly wanted to dive into the agenda. Jay, do you see the title slide, or is it just me? Or
no, I don't. Yeah, I'm like you.
So let's try this again. Florence, now I don't see any slide anymore. Nevertheless, let me continue. Again, I quickly introduce the speakers. They will introduce themselves afterwards. And the agenda covers, or will cover a brief introduction. We will then listen to the speakers, and then we will have time during the roundtable to ask questions, discuss, and also debate openly. This will be moderated by Florence from Capco. The closing of the webinar will be done by myself and mostly Jay. And just as information, questions during the webinar, you can put them into the chat function of your system. We will try to pick some of them up during our Q&A. So I'm happy to continue, but I still see the presentation, which again should not be about the presentation, but gives us some guidance. I will ask again to my fellow speakers, is that just me, or do you see it?
No, we can't see any slides either, but yeah, that's fine.
Okay, Lawrence, try to put them up. Let me start with a couple of thoughts from my side as an introduction. Can machines think? Is a question that great minds have been debating since Asimov in 1942, first time being formalized by the Turing test on the Dartmouth conference in 1956. Before we dive into our discussion and listen to the thoughts of the panelists on whether machines can actually think, let me take a quick step back and think about rather recent technological developments that great human minds have given rise to in the past. We've been fortunate enough to witness great inventions such as the AI AlphaZero by Google that is used in the gaming industry, for instance, or tremendous advancements in the field of image recognition that are now implemented actually to detect cancer in humans, to only name a few. These examples show that, without doubt, the field of machine and deep learning has enabled us to advance into previously unknown territory. Not only can ML and AI help us inform more accurate and precise business decisions, with the help of these technology, we can solve challenges that human minds until now have struggled to overcome. So even though it seems clear that we have benefited from these technology in numerous ways, one specific question inevitably comes to our minds, at least to mine. Do we need to fear that the ongoing process of automatization will challenge us for our jobs? Will machines eventually take over the world? What is there really that sets us humans apart from machines? Many experts assert that as of today, no machine is actually capable of informing proper decision on its own without the help of some sort of human assistance. No machine actually walks around solving interesting or relevant problems. They not only enjoy winning, they do not enjoy winning a game of chess, nor do they understand what it means to detect cancer in a patient, thereby helping to cure his or her disease eventually. Machines respond to a predefined set of data and solve predetermined problems. While on the other side, it's undebated that computers do a great job in learning and solving problems, they certainly do not conceive or perceive a world or our world the same way we humans do. For this very reason, the job of us humans is to make sure that machines learn from clean and precise data to overcome the issue of, for example, garbage in, garbage out. Indeed, if the machine really was to understand what it's doing, it would be able to rightly detect on its own what proper and accurate data is. Hence, machines, in my view, need humans to monitor and conduct data management, for example, and to choose most accurate and suitable models to solve a specific problem. Now I see the slide. Again, thanks for putting this up. In this context and around my thoughts, I just wanted to quickly give you a bit of insight how Capco's methodology works when it comes to precisely these interactions between humans and machines. Our methodology centers around questions regarding data management and data analytics. Specifically, one of our jobs in this context is to understand how data solution can be operationalized and in an organization and help the organization. This entails aspects such as data governance, lineage, ensuring data quality, and so forth. To cover all the relevant aspects of our framework within our broader digital delivery practice and our data projects, we rely on our so-called 3x6 approach: explore, experiment, execute. 6 days exploration. In our data requirement workshops, for instance, we identify which problems our clients aim to solve, meaning where do we want to go? Or our data maturity assessment measures the status quo of an organization along the 8th dimension of the data wheel, meaning where do we stand? Then in the experiment, in the 6 weeks experiment phase, we automate the workflows around data procurement, data analytics, and model evaluation to experiment possible solution options together and for our clients. Then the execute is based on the outcome of the exploring experiment phase. We give our clients a well-founded basis for decision making by developing and testing an MVP. These are, from our perspective, the current and most important challenges in the data world of the financial industry that we deal actually deal with on a daily basis. With that being said, now let's soon listen to our panelists' thoughts on the challenges and hurdles of our world of data today. Before we do this, I would like to pass the word to Jay. Jay, again, thank you very much for hosting this interesting and exciting event and for bringing together different talents and viewpoints and excellent speakers. Thank you. Over to you, Jay.
Thank you very much, Andrea. In fact, I want to be the one who wants to thank you and Florence for putting this together with us. It's a very, very, very exciting subject, which I am very passionate about. More so because I think AI is actually it infiltrates all other technologies. And for us, technology is a major solution of what's going on in the wealth management industry. You know, our dream started 4 years ago. 4 years ago, we sat down and said to ourselves that instead of embracing technology for wealth management, why don't we work on leading it? Where are we at the forefront of technology as far as wealth management, private banking is concerned? Because the issue with private banking and wealth management is that it's right now going through turmoil. There's a big change, a big movement that's happening. We won't get into the details of what's changing in wealth management over the last 10, 20 years, but certainly everyone's heard about this major transfer of wealth from the baby boomers that are retiring to the younger generation, this transfer of wealth where women now are coming into the workforce and into businesses. And more importantly for us in Switzerland, the Swiss banking secrecy having gone. So because of these changes that have been taking place, some of them having been caused by technology, we felt that technology could be a major solution to this turmoil in wealth management, if not only a solution, but a major opportunity. If we could work in wealth tech and form wealth tech, which we call the Geneva WealthTech Forum, we work very closely with the state of Geneva to put this together as a dream, whereby we would take the key players in the financial industry and the key players in the technology industry and start a dialogue, start a communication on how we should enhance and how we should work on wealth tech to strengthen the financial world. But the truth is that technology can help us, one, go get clients. So if Switzerland doesn't have the Swiss banking secrecy and our clients are not coming to us, we should be able to reach far and wider audience of clients through technology. We should be able to better manage their assets. And we should be able to streamline our services and our businesses to make them more efficient in a cost perspective. So we're passionate about this. This journey, as I said, started 4 years ago with the Geneva WealthTech Forum. And the initiative that you've taken with us on this AI is a testament to that. And I'd like to keep the rest of what I would like to say at the end in the conclusion, because I think the audience wants to hear these wonderful speakers that we have. Florence, shall I pass it to you?
Yes, and thank you, Jay. Now we will have the first speaker, Mohanty, who will speak about the subject. What do skeleton strengths and tax policies have in common? So Mohanty, the chair is yours.
Thank you so much, Florence. I was curious if I could just share my screen because I had some slides. Florence?
Sorry, it will be a little bit difficult, but if you try.
I'll be happy to, because there's some slides, because many of them they do have, but where exactly do I check that?
On the screen, on the left.
Mm-hmm.
And digital TV.
Can you see my screen right now?
Yes.
So yes. Yes, it's okay. Yes.
Okay, as long as you see my screen, I can get started.
You might want to go to full screen, but then it's perfect.
Yes, that's perfect. Monty, if you want to.
All right, thank you so much for your patience, because I really wanted to kind of have the slides so that it's a little bit easier. So my name is Mohanty, and I'm the CEO and co-founder of AI Crowd, which is a small project I started while doing my PhD. And it's a platform where we do research in artificial intelligence. And it's actually a community of the people that we have been trying to build. But in this talk, I will not be talking much about AI Crowd. We'll be kind of giving examples of some research that we have been kind of doing. And we'll try to answer what do skeleton, trains, and tax policies have in common. And sounds like the beginning of a joke, but yeah, it's just talking about research. Chapter 1 is about skeletons, and it's the story of Bob. Bob is a simulated skeleton which kind of found its existence in a part of my research when I started my PhD. And the whole goal was simple. The whole goal was Bob has 18 muscles in the lower part of its body, and you have to imagine you're like a puppeteer. Whenever you send a signal of 0, it means all the muscles are completely relaxed. Whenever you send a signal of 1 to any of the muscles, it means the whole muscle is completely contracted. And you have to basically figure out how to coordinate all these signals to all the muscles, pretty much like a master puppeteer, to figure out how Bob walks. And that experience was a very interesting experience. That experience was an interesting experience because when we started kind of working on the problem, Bob would fall face flat, irrespective of whatever we did. But we got a little bit better. Over time, we kind of trained these models which would figure out how Bob learns to take 1 step, 2 steps, 1.5 steps at a time. At a point, Bob started trying to act a little bit over smart, because the whole goal was how much further you can move. It figured out that if I do a perfect dive, then I'm covering the most distance. And then after adjusting for a whole lot of other such things, we kind of finally taught Bob how to kind of walk. But this was not the most optimal walk, because it learned that hopping is a lot better, because we were not taking into account the notions of energy considerations. And finally, after a lot of jumping around, after a lot of shenanigans that we had to pull forth in context of research, we taught Bob how to kind of walk, very much like humans learn how to walk over millions of years of evolution. Now, at the end of all this experience, Bob was actually running really fast enough to qualify for the Boston Marathon. But how did all of this happen? All of this happened because we put up our research out there on a platform where hundreds of researchers all around the world came in together to kind of teach Bob how to walk. And in the process, we had about 2,000 different alternate approaches on how Bob can actually walk. And the whole thing happened on this platform. It used to be called as Crowd AI. Now it's called as AI Crowd. And it's an open platform where many people collaborate together to solve hard problems. And along the way, while we were kind of building this community of people who are interested in teaching Bob how to walk, we realized many people were kind of doing this while they were learning how to kind of work on many AI problems. And they were just excited about the fact that they got to learn along the way. And there were also many people who were a little bit more aggressive, but these aggressive stances were also some things which were kind of teaching us many weird nuances about how we were doing our research. Traditionally, we would do our research in a siloed way in a small academic circle. Now, on opening up, we got multiple points of view, but also very good constructive criticism. Some of them were a little bit more extreme, but still had numbers to kind of back them, and feedback which helped us improve. But overall, irrespective of all the kinds of feedback, all the modes of feedback, we absolutely love this community of people who came in together to solve a problem that we cared about, to teach teach Bob how to walk. And that was a hard problem when we initially pitched the problem in context of reinforcement learning. Now this is something we realized that it is kind of something we can solve. And just because we had access to these community of people who were passionate about this problem. But how did this happen? When we got started, of course, we had to incentivize the community to work on this problem. And there, NVIDIA kind of came along and they gave away this NVIDIA DGX-1, which was a huge supercomputer in a box, which was hugely attractive for a lot of people to keep working on this problem. But at the same time, the problem was kind of framed as a reinforcement learning problem, where the whole notion was Bob lives in a simulated environment. And then agent is an AI that you have to train, which has to kind of act on this environment, and the environment gives a reward. Reward is based on how well you're kind of acting. And the same format is something that has been used by numerous research organizations to kind of solve a whole variety of problems, which usually revolve around games. Can you teach an AI which can play an arbitrary number of games without any hard-coded rules? Which brings us back to the chapter 2, which is on trains. How do you extend the same idea on how you can bring up this notion of environments, agents, actions, and rewards, and then take it to trains? This whole thing started at a meeting, at a chance meeting I was at the SBB headquarters in Bern, where we were talking about how trains are scheduled, and by the end of the meeting, a bunch of engineers from SBB who were very excited about reinforcement learning, and me and some other friends, we started nerding out on a whiteboard on how we can frame the train scheduling problem as a reinforcement learning problem. Over a couple of months later, we actually designed a simulated environment in which your whole task was to kind of play this as a game where you had to figure out what the trains need to do so that all the trains, the overall delays in a large network like this is kind of minimized. And that kind of led to this Flatland project, which is a collaboration between AI Crowd and SBP on how to schedule railway networks by using reinforcement learning. But we also did the same thing that we did in context of Bob. We designed a challenge around it where we put in a lot of work to ensure that anyone who wants to contribute on this problem can jump in and start kind of working. And we put in a lot of work to ensure, irrespective of your background in scheduling railway networks, reinforcement learning or whatnot, you had enough resources to get started on this problem. And at one point, NeurIPS, which is one of the best conferences or the most popular conferences in AI, they kind of started promoting this whole thing as an official competition. And we had hundreds of researchers from all around the world who jumped in at this idea that can we actually schedule railways in a simulated railway network for SBB, which has the reputation of being rather punctual. But along came Deutsche Bahn and SNCF, who also jumped in and said, we want to kind of help make this open research initiative a success. And they put in resources, many of their really excited team members, and more people started coming in. And over this whole time, we had about 2,200 submissions, alternate submissions on how to schedule railways in large railway networks. And we had about 700 people from all around the world who came in with alternate solutions to for this particular problem. And in the whole process, we, again, as I mentioned, we made it sure that as soon as you jump into this problem, within the next 10 minutes, it was a rather bold claim, but I think we stuck to it. In 10 minutes, you are able to kind of ensure your solution is somehow kind of is seen on the leaderboard, and you see yourself among this large sea of many other researchers who are working on this problem. And at the end of the day, what is actually happening in a simulated world? These little trains are going around. But over time, as you start looking at more complicated situations, what is happening is we are getting these thousands of submissions on how to schedule trains in a railway network, and we are trying them on hundreds and thousands of simulated scenarios that has never been ever seen by these networks. And we have an empirical way in which we can select which ones are the best solutions that are available. In the process, we engaged hundreds of researchers from all around the world to solve a problem that we were passionate about and had a huge economic impact at the same time. So our first experience in context of teaching a simulated skeleton how to walk by building a community of hundreds of researchers was not a fluke. This is something that can be replicated. And that's what we did in context of Flatland. In the process, we created an open research initiative. Now, this also was this whole framing of a reinforcement learning problem where you had an agent, environment, and reward. And in interest of time here, I would just quickly touch upon this another example. This is not research that we have done in-house, but this is research by Salesforce, where they designed this notion of an AI economist. I wouldn't play this video per se, but I will quickly try to skim through some of them, where the whole idea was to kind of design a simulated economy in which people would go in, kind of engage in economic activities, and the task or the whole game was to design optimal reward policies or optimal tax policies to ensure that the overall productivity and equality balance is kind of something which is well balanced, and overall it's kind of the best way in which we can design a tax policy given that setup. And the whole thing was learned by millions and millions of simulations like these, where the agent basically learned by making many mistakes in the beginning and eventually converging on a policy which was the best. And here also, this is not something we have actually done as an in-house research, but we are on the verge of kind of opening this up as an open research initiative, where we want to engage millions of people to kind of come up with reinforcement learning approaches or AI approaches which can design tax policies, which would eventually hopefully impact millions more and billions of people in the long run. And this approach of building communities which solve hard research problems, where you yourself would have to kind of work a lot to kind of find these initial set of people, is something that is not something which has been a fluke. This is something we have done over and over again, from teaching AI models on how to play Doom, to teaching AI models how to play Minecraft, doing collaborative and competitive tasks, to more Minecraft, then teaching AI models how to kind of drive using video feedback, and or how to hack other neural networks, or look at satellite imagery and predict what disease, and predict where they're the buildings, and or look at images of snakes and predict what species they are, or food, and a whole lot of other such examples which are at the state of art in terms of how AI research is done or how people perceive the problem, but engaging hundreds and thousands of people who wouldn't immediately identify as old school and classic academics, but people who are curious about AI and want to solve these problems. And one of the reasons why we are kind of very passionate about making this happen is we want to kind of build, we want to build, something is off. Why we are so passionate is because we want to kind of build an open knowledge graph of reproducible solutions for many problems that we care about. And the reason we want to do that is because our ambition is to be a distributed research lab which engages millions of researchers all around the world to solve problems that matter. My question to you is, do you have a problem that can be tackled by our community of researchers? If so, please do reach out. Thank you so much.
Thank you, Mohanty. Maybe we can have the end on the presentation.
Sorry?
Yes. So thank you so much. So we will try to go on the next presentation, and we will have the next speaker, Dr. Miguel Noguer y Sales y Alonso, founder of Artificial Intelligence Finance Institute. And Miguel will speak about current trends and application of AI in finance. Miguel, the floor is yours.
Yeah, thank you very much. So I'm very glad to be here among these great speakers, and I think this is a great event. So we're living exciting times. We're living exciting times because we're obviously having so many challenges on our tables, modeling challenges, data challenges, and we think this is an exceptional, or I think this is an exceptional moment for financial modeling, quant finance, and finance in itself, right? And it is because we're now starting, so all companies, financial institutions, starting, well, some of them have already started a couple of years ago, 5 years ago, to use AI techniques in finance. And now we're seeing also, obviously, supervisors, right, trying to work on understanding these models and so on. So I'll be talking about reinforcement learning, obviously, a bit, right? And so that's on one side. So I'll speak about this, but yeah, I think on the other side, we live an exceptional moment in terms of an unexpected guest, which is that we tend to say AI needs lots of data. We say econometrics needs a lot of data, financial models needs a lot of data. Well, we're actually living in times which is very scarce, right? And we were talking about that yesterday, and it's because the confluence of things. So think about the replacement of LIBOR is causing some sort of a huge, debate among interest rate community because of, and there's a scarcity of data. This is just starting, right? We have the COVID, right? The COVID, it's obviously something that just some sort of changed, right? All the data sets, right? That data scientists were using in banks, asset managers, supervisors, and so on. And now they need to think how they can create this new data. So it's not even here. So the idea of we're going to be needing to create artificial data very soon, right? Again, to try to tackle these issues. And then there's obviously the fact that supervisors, consumers, everybody, needs that we use proper data, right? So that's one of the other things. So if we think about it, AI in finance, it's not only about algorithms. We tend to obviously train students on algorithms, and they're very good, but it's obviously also the other part of the equation is data, right? And data is absolutely very important, and it's a moment of tremendous change that will need from us and regulators and the community a lot of effort, right? So I have put together here a few bullet points that I think are really very important, right, for financial institutions, asset managers. One of them, it's classification models. Classification models came to us relatively close, right, or relatively recent, right, because traditional econometrics, traditional financial models were not models that were classifying things, right, in general, right? So I think AI, machine learning, has brought to us the idea of we have very powerful classification models, probabilistic models, and so on and so forth. So now we can use that to ratings, to measure probabilistically, ESG classification things, which is another important use case. So I think, and also supervisors have embraced the idea, this new set, it wasn't new, but we are now more comfortable into using classification models like super vector machines or trees or XGBoost and so on, right? That can help us with several tasks. So I think this is a big change, right? The other change that I think probably is going to be first, right? So it's natural language processing, which is obviously, right, a huge, I think if we have to name two things that we've never done, right, is obviously we've never run, text analytics, right? We've never run, right, deep learning models, right, or natural language processing that allow us to some sort of digest, analyze huge amounts of data. And these models are new, right? These models have millions of parameters. These models require a lot of tweaking, a lot of supervision, right? And let me say something about Andrea's introduction, right? Most of these models require adult supervision, right? You're not letting algorithms just run wild, right? Because they will be performing extremely important tasks for the banks, for the asset managers, for risk managers. So you're not, and data might change, algorithms you might have a bug in the code. So all these models, while they're powerful and they can do non-linear classifications, regressions with huge amounts of data, which is a very important use case for asset managers that have thousands of stocks and banks that have millions of clients, right? So it requires adult supervision, so domain experts. So you still need the risk experts to look at the outputs of the model. Is this something plausible? Is it something normal? Should we dig more? And so on and so forth. The third is what Sharada mentioned about the huge promise of reinforcement learning. So reinforcement learning is able to, basically you can do everything in finance. In finance, basically everything is about prediction, optimization, right? So many things, portfolio optimization, risk optimization, what else? Option pricing. It's all about functional approximation, supervised learning, but also optimization. So here, the promise of reinforcement learning, it's very important. At the same time, it's exactly what I just said. It needs adult supervision. So reinforcement learning will learn things from the data, maybe things that humans never learned, maybe things that the humans never figured out, right? But we still think that reinforcement learning, it's going to be one of the main areas of development in AI. We actually wrote recently a paper that you can find on SSRN called Deep Reinforcement Learning for Asset Allocation in US Equities that I co-authored with Sona Srivastava. And there we some sort of use deep reinforcement learning just to do everything from picking time series of 25 stocks to putting together a portfolio. So it's a time series prediction problem and an optimization problem. Actually, nets learn how to do that in a model-free fashion, right? I'm not saying, so this is opening, again, new areas of use. And maybe fourth is what I've just said about assessing, working on interpretability. So folks working for banks know very well, I ain't implementing any model if the regulator is not agreeing, is not interpreting my model, is not so understanding what's going on. So I think part of our jobs has been on the more risk committees. So go there and say, okay, this model seems to work better than I don't know, seems to work better than Austin-Uhlenbeck models or the benchmark rate models, right? So, but how can we interpret it? So assessing and working interpretability, it's a very important aspect for regulators and also clients. We should be able to say, okay, why we choose Apple for next week portfolio? Why are we not using Microsoft, right? And so on and so forth, right? And then obviously all the privacy aspects that arise that are very frightening about the use of data out there. So sorry about, yeah.
Thank you, Miguel. And it's very interesting to see that finance and the use of AI is a kind of game changer, and for the asset management and for the financial institution. Thank you for this great presentation.
Thanks.
Now we should go to Neil Stillman, the next speaker, Chairman and CEO at Rivi. He will talk about a very interesting subject as well, data humility. I don't know if you have heard before about humility, sure, but data humility. Stay and hear the presentation from Neil. Neil, the floor is yours.
Thank you, Florence, and thank you to my colleagues on this call. It's an exceptional learning opportunity. Today, I'd like to spend a few minutes talking about humility. I would suggest to you that 2020, this year, has been a terrible year for humility. And it's probably been a bad year for humility for several years. In the data community, I think the biggest and most famous failures in humility were first pretty unanimous prediction models that suggested in the public health community, of which I am a part, that we would vanquish COVID-19 by May. Secondly, and most recently, a quite ubiquitous consensus among traditional pollsters in the United States and around the world that we would see a huge big blue wave rather for President-elect Biden, where he would win 390, 400 plus electoral college votes. This is a failure of humility, and humility is something that both machines and humans suffer from. And so we need to impose humility on the machine, and yet we suffer from a lack of humility. So I just want to speak to 4 points in this regard. I want to talk about humility as being the essence of science and innovation. I'm the son of 2 brain scientists. This is something that means a great deal to me. Secondly, humility and data humility in particular being about testing our assumptions. Third, humility being about taking privacy very, very seriously. And fourth, humility, data humility in the new era of COVID in particular, being about learning from other countries. And so first, about data and innovation. So, you know, my daughter, she's been going to the same school now for 7 years, and yet she asks me why she still gets ads when she searches online for her to enroll her children in the school she attends. Both of our children do not take seriously the content of non-prominent content on Wikipedia, and yet Wikipedia powers the AI engines of some of the most sophisticated AI tools in the world. Neither of our children, nobody we know, answers authentically, truthfully when they see display ads and little surveys online before they get to the game or information that they would like to see. And then most problematic, most recently, of course, is that we were promised by social media companies in 2016 and repeatedly up until 2020 that their so-called AI algorithms would expunge both disinformation and misinformation on their social platforms, which are very problematic. And of course, we had nothing but the opposite take place. And I would suggest to you that we have to be very humble about where we are at in the current era of artificial intelligence. As Sharada mentioned, as we've learned from Miguel, I mean, we're doing some extremely exciting things. But if we overpromise and underdeliver, as we did with personal genomics and a number of other great innovations of the last several decades, we will lose public respect, public credibility on that which we are trying to do. And secondly, sort of testing our assumptions. You know, we are a data vendor for the finance community around the world, for the international security community, for the humanitarian aid community in all countries of the world. And, you know, we're often asked to backtest our data, So independent of all the problems we all know on this call about overfit models and easily being able to, let's just say, adjust your backtested data, there's a bit of a cognitive error that comes into play when you say backtest in the era of COVID-19 or in the era of a situation where you have just one country, China, being able to have a positive GDP in the current year, as far as we're aware. And so what this means is that, you know, 2019, 2018, even the first quarter of 2020 are essentially meaningless when you're considering backtesting. We're in a new age now. COVID-19 from a public health perspective was a known unknown. But what we face now is a suite of unknown unknowns that relate to how vaccine efficacy, vaccine distribution, vaccine regulatory approvals, vaccine ethics, and a number of other things that make what we call in the data ecosystem, we're in the midst of what I call both a complex and complex dynamic system, where things like backtesting, let's just say, have to be understood within the reality of where we sit. Third, data privacy. So in the ebook for Geneva WealthTech that my colleague Apoorv, who's going to speak next, and I discuss, I mean, we speak about the importance of taking privacy very seriously. You know, we're in a time now where any information that is inputted online, even if it's de-anonymized, can be essentially re-identified using machine learning. And this has been well established in publications in Nature and elsewhere. And more importantly, from a data veracity perspective, is that the public knows this, especially younger cohorts of individuals. Our kids studying machine learning and coding in school, they know this. They know they're not anonymous. And this partially explains, of course, why traditional pollsters do not get accurate information. They have a fundamental instrument error using flawed instruments that no longer are relevant in the new world. And it also explains why anonymous data collectors and AI tools and machine learning tools can more accurately assess, both in the United States and China and around the world, investor sentiment and consumer sentiment. And then fourthly, sort of, you know, learning from other countries, in particular China. I feel that the biggest public policy error or public health error in the pandemic thus far has been a lack of humility and a lack of willingness to really learn from other countries at different stages of their own epidemic within this global pandemic. China, of course, being the best example, which uses different policies and approaches to managing its epidemic, and yet we can learn a great deal from the Chinese consumer, from the Chinese investor, in terms of what will be resilient in the global economy, in our own economy. And we should be resistant to the media narratives about what is happening in China and really investigate that using data. And I think that's an exciting opportunity for artificial intelligence to really understand the truth, which is the foundational element of wisdom. So thank you. And with that, I'll finish and pass it over to a very wise man, Apoorv. Thank you.
Thank you, Neil, for your presentation. And now we know a little bit more about data and humility. And the focus of today is about thinking, but one specific aspect of human that they are making mistakes. And so we have the pleasure now to hear Apoorv Jain, CEO of MicroX Studio, former visiting researchers of Harvard Business School, and he will talk about the 4 main practical mistakes in applying AI to asset management. Apoorv, the floor is yours.
Great. Well, thank you, guys. What a great event. And humility was the great segue, I feel. Couldn't have arranged it better. I don't know if AI did it or I think human intelligence did it to the talk. So I want to share a story with you guys about a trading model that misbehaved. Okay, so everybody talks about the trading model that does well, but I want to talk about a trading model that misbehaved. So I was at Microsoft and I had this amazing mandate, like take these 10 people, so kind of amazing researchers from Microsoft Research, some of the best computer scientists in the world, take $100 million and invest it, and then you have all the infrastructure, lots of data. And now make money out of it, right? So that was the mandate, and for 5 years we did that. So we made this model, and it really broke new ground. Like it was about how investor mindset works. So this was research, we presented it at Harvard too, like research that we had not seen before. So it was beyond kind of sentiment. So it was a little bit more on things like investor mental state using linguistic entropy, attention. So things that are now much more, a little more mainstream, but were really not mainstream then. So the model was great. The research was exciting. And then we actually started trading it and it did better than we expected. So we're like, what? So the model actually performed better than we expected. And then of course, senior management got very interested in it. And there was a lot of buzz around the project anyway, so everyone wants to look at it. And then, of course, we were going to present the model, and it starts doing really poorly. So we're like, unbelievable, or rather, very believable. As soon as senior management looks, you're like, it's doing so badly. So now I want to talk about what happened then. Okay, so there were 3 kind of types of responses. So I classified them as tribes, and the slide may be a little hard to read, but basically, and if you had more time, I would kind of play it as a game of what would everybody think we should do. So one, kind of the trader PMs were like, either you could not print what they said about the model, or it would be like, you got to stay the course, you can't change it until you hit a stop loss or something, right? Then all bets are off. So that's kind of the trader or portfolio manager response. And the data scientists were like, I knew I should have either done reinforcement learning or used a different approach or should not have done SPMs or whatever. So they wanted to go back, kind of refit the thing. And researchers were like, not seen this. This is a paradigm shift and not seen this before. Give me 6 months. I'm going to go and think about it and come back. So so that led me to reflect on kind of what were the strengths and weaknesses of each tribe, so to speak, right? So trader and PM, I realized had very good intuition, but some of us, and I speak as a trader myself, I ran a $3 billion portfolio for Microsoft. So as a trader, you know, we tend to be very arrogant. Like nobody would accuse us of humility, I think. And, you know, we are very blind to our own cognitive biases. And then as a data scientist, so typically, you know, and that's kind of, I'll now put on my kind of researcher or scientist hat, like many times we lack context but don't want to admit it. So that leads to either bad data or whatever, or the belief that you just need data when in fact the context has changed. So you know, so that's, and then of course they are very good at actually, you know, fitting the models, as traders are good at intuition. And then the researchers, we typically tend to be pretty good at systematic frameworks and then learning in a way that you will actually move forward over time with little experiments. But, you know, we fall in love with theory, you know, so University of Chicago, where I attended, and had this famous t-shirt, it's great, it works in practice. How does it work in theory? So you're like, so this kind of love of theory, or this like, oh, I love something interesting more than relevant, and that's always kind of in Microsoft research. I try to pull in a research, be like, but is this, I'm just doing this really interesting thing. You're like, but what's relevant is that? And then so you would have this battle. So that kind of made me step back. And so eventually what happened was, you know, Twitter had IPO'd and some of our data feeds had changed, and we actually ended up being a data problem, and we fixed it and it was fine. Senior management, I don't know what they thought about it to this day. But so then I kind of went back and said, okay, what can I learn? What can we learn from this? Okay. So in a sense, I could pose this as a data problem, right? Like, which it seemed like, right? There was an IPO and then the data feed changed and some of the, you know, so it's like, well, that's maybe a data problem. You step another level, you're like, well, no, maybe it was a technical problem, because we should have had things in place that identified, you know, that the data changed, or we should have been using a different type of model. That seems like a technical problem. So then you can step back even more. It's like a conceptual problem, like where you're like, well, should this type of model have been allocated that type of capital? So conceptual problems happen when you're really trying to understand how to take something from kind of the technical side and what is the business use for it. So that's a very typical place that I see conceptual problems arise. So one quick example, another example I'll give you is, for example, you have two types of models, and ensembling them is a very, you know, it's a very simple technique, and then it's going to produce better results. But sometimes one type of model is something that everybody has confidence on. So this is in a sense the human aspect. So let's imagine it's kind of like a value factor, if you will. So even if it does well or not, for a long time, people have a lot of confidence, so they might stick to it, so to speak. Right? On the other hand, you have another set of features or model which are hard to explain, or you've got from, let's say, deep learning. You can't explain it, but that type of model, you're going to judge by its performance. So if it starts performing poorly, you're going to turn it off faster. So your trade-off, the utility function, so to speak, for both of them are quite different. But if you ensemble them, which leads to a better statistical prediction, but in a portfolio sense, you put them together. Well, now you cannot. Now you've conflated the decision rules, so you would not turn off the first one, even if it did a little poorly. You would give it more room because you understand it. The other one you would turn off faster, and if the two are combined, it's very difficult to know should you turn it off or on. So that's a type of kind of a management or conceptual problem that potentially we had. But the real problem, the biggest problem that I realized was what I call the organizational problem. Okay, so all these tribes cannot speak to each other, and when they cannot do that, that's the organizational problem. Okay, so so for example, a lot of asset managers, they were not built with technology or alternative data as a fundamental building block. That's seen as a helper, right? So that's a little outside the domain. So you bring in, or you're a data vendor and you come in and you give us your stuff, you toss it over the fence, we're going to take it and do something with it. So when you do that, like the iterations are way slower. So it's a little like a game of telephone, and the iterations become very slow. So the three tribes I outlined in the problem that we faced, right? If those three tribes, like when they were calling each other, or just as soon as a problem hit in a time of stress, they were unable to coordinate effectively, right? So then what helped, right? What worked was sit together. It's very simple human things. Like you have to sit together. So all of us sitting together, kind of having this, developing a trust, and then really crucially learning to speak each other's language. So for example, we then had a rule, like for the team that I ran, we had a rule that everybody had to be, we call it a black belt and a blue belt from martial arts. I'm into martial arts, so I call it like that. So kind of black belt is something you're really good at. You're an amazing trader, but you have to get a blue belt. Okay, so the beginner proficiency, you have to get a blue belt in data and as a researcher. You have to do those two things, at least one to come in, and then hopefully two by the time you're kind of a big part of the team. So when you do that, then you can really communicate and collaborate effectively. Otherwise, you completely lack context of what this other expertise is doing. So the black belt still does the black belt thing, but you have to understand and kind of be able to do stuff with them. So actually, so as we implemented that, so that was the kind of one of the biggest learnings I took away from Microsoft of having these, interdepartmental team and herding it through 5 years, was that, if you enable that communication and develop that trust and develop an organization like that, that's how alpha is made. Okay, that's how alpha is made. Alpha is made when you organize your team according to what you think your alpha source is. If indeed your alpha source is going to be iterating through new types of data fast, then your team should be organized so they can talk to each other. So I'll leave you with that. Thank you very much.
Thank you, Apu. Now we will go to the roundtable in order to go deeper into the use of AI in finance. In fact, it's a game changer. It's changing the business landscape. According to Forbes, 50% of senior financial management expect positive change for the use of AI. Some participants or some bankers or financial people from the banking side use AI, some other are more cautious. So you're using AI from your day-to-day. What challenges do companies face in applying AI to asset management, to finance in general? Maybe, Apu, if you want to go deeper into the aspect of the use of AI in asset management and the challenges.
Sure thing.
Already seen?
Yeah, I mean, I feel like a lot of the panelists touched upon it already. Like Mikhail talked about, if you look at the data, explainability, I think is a big challenge. Interpretability, explainability, having clean data. So and not to kind of repeat the 4 things I said. So the data challenges. So getting not garbage data, right? That's a big challenge. The technical challenge, I think, is getting the right people as well as figuring out the right techniques. And to Neil's point, kind of not being obsessed with the backtesting mindset and understanding that sometimes, right, you're either in an unknown or a new unknown. So how do you deal with that? And that's also kind of veers into the conceptual challenge. The organizational challenges are, I think, quite big, as I mentioned before. It includes very simple, like finding the right people who kind of have the intersection of both. So for most firms, it seems like finding a unicorn. And then I think it goes all the way to how should you organize your team. So I'll kind of, others kind of speak more, because we obviously have Jay and Miguel and Neil, and everyone's kind of, has a deep finance expertise.
Yes. Yeah,
Yes.
Yeah. No, I was saying everybody is all big firms, small firms, right, are some sort of having maybe they have big data teams, which is basically the same thing, right? So it's basically finance is a domain in which we have a lot of data, but this is but let me rephrase a little bit in a second. But so we have thousands of stock that we need to track, right? So your portfolio managers probably can't do that, right? You need to also look at hundreds of factors, maybe 200 factors that you want to look at about the different companies. So I always tell delegates and practitioners and students, so whenever you have a largely dimensional space, and well, you have to use the best tools we have, right? Are machine learning models, so to speak, right? And this doesn't mean they're going to be perfect, but the best tools we have that we have found so far is machine learning models. But at the same time, I really agree with the fact that you can't be too naive of thinking that this is going to completely change things, and all of a sudden now be accuracies of 90 instead of accuracies of 55, right? So this is not possible in finance, right? So in finance, there's a large degree of unpredictability, right? All practitioners that have used econometrics, machine learning know that, right? So I really think that all folks need to learn machine learning, econometricians, data scientists, obviously, right? And at the same time, right, data scientists need to know about finance because it's a specific domain that it's very hard, right? And they typically tend to give up too quickly. So you pick deep learners and they say, oh, this I have a bug in the code, this is not working, right? And say, yes, it's working. I would be surprised if it was much better, right? And let me say something about the data again. I really love the data community. I think the biggest challenges are the fact that in finance we oftentimes have small data. We think we have big data. We oftentimes have small data, right? And we have maybe 10 years of data. This ain't much in a statistical terms, right? So and things can change, right? I think that we've all learned after years on the business, things change, right? We had the financial crisis in 2008, we had the tech bubble in 2001, now we have COVID. So all we've learned is that literally anything can happen to your portfolio. So you need to be very flexible, very humble to change. And just maybe one final comment on data, samples, and right. So practitioners need to be very careful about the sampling, right? And this is also an art, right? And let me say something about the US elections, right? So if you have time, you have to read. There's a paper by Xiao Li Ming talking about statistical paradises and paradoxes in big data, and you learn a thing about what makes polls so hard, right, for the elections. So this is a specifically very hard issue because polls are not a good sample for the rest of the population because there are lots of biases in the polls, right? So literally AI, machine learning, all the algorithms, right? You need to be extremely careful about the potential things you inherit about the data, right? And things can be as hard as, yeah, we were forecasting right Biden or Clinton with a huge difference, and then things were different, right? So data is very important, right?
I'll make a super quick remark about when people said, oh, something is wrong in my code. So that was a very frequent experience for me at Microsoft. The researcher from other domains would come in and they would expect to just kind of crush. They would be shocked if their R squared, so to speak, kind of suit R whatever, right? So our mean square error down was not like high. And I'll be like, dude, if you can actually perform 5% better than random and you know it, that's huge. But to get that around, to get kind of like you're already competing with some of the world's, this whole economy is a giant computation engine already. You're competing with that. It's not, so that kind of concept to sink into their mind, that takes a while.
Thank you. I'd suggest that, building on Apoorv's overview, that I'm a member of a fourth tribe, which is the data vendor community. And the way in which the finance community buys and procures from the data vendor community is fraught with organizational challenge and misaligned incentives. Our company comes from the world of pandemic surveillance, originally during 2011, and international security during the Arab Spring. And yet, there are a number of challenges and biases when you're procuring data. One is that you think, oh, well, we should only buy data from people who have pedigree within the financial services community. I think that's pretty limiting. And number two, there's this idea that more data feeds are better than fewer. And of course, this is a misaligned incentive because you have quantitative experts within your hedge fund who are incented to explore and play around with many, many data sets. And this is a problem that will actually inject your formula by definition with more noise than signal.
If we go deeper into data, we heard a lot today about alternative data, but what do people look for in an alternative data source?
Yeah, if I may, yeah. So there's two things, right? One is obviously signal. So one particular data and when we weigh signals, I agree with Neil, right? You typically looking for some sort of like high frequency. So you have lots of data points, right? And you have some sort of a statistical certainty if that exists, right? So this is one thing, but quants have to evolve and need to evolve to a kind of data sets of maybe less data points, but more informative, which is a real challenge, right? It's a real challenge for quants now. Instead of having some sort of daily data, having even sparser data, right? So literally you measuring your investors say, you want to measure ESG for us? And you say, yeah, the problem is I don't have information about the CEO every day of a company. So in general, nothing happens in a normal day for the CEO of Apple or something something that we can. So I think this is a very important aspect of and quants for the first time are needing, right, the domain experts, in the sense that we need to figure out if this is informative instead of statistically significant, because we know statistically significant cannot be with a couple of data points, right, or 3 or 4, right? So it's like COVID-19 at the beginning. Yeah, quants were saying, okay, but this is a very small data problem. It can fit anything. Anything can fit 4 data points. Anything, any function you might imagine, linear, nonlinear, exponential, whatever, deep learning, and so on and so forth. And then you had to go to the domain experts to say, I need your advice because it's a small data problem. I don't know to what extent these points are informative, the sample is good, and so on and so forth. So there's a lot of challenges of information, some sort of impact, and statistics. So there's a nice trade-off. It's a very hard one.
So on my side, I would say I really love the comments from Mikel. Building upon that, I look for 3 things. Is it unique? Is this data set, right? Is it somewhat orthogonal to what we have? Is it unique? Is it going to be more accurate in some conceptual sense? So not statistically testing, but just, is it going to help us be more accurate on something? And then third, of course, is it really important? Like, is it informing us about something important? Because most data, to Neil's point, most data are actually not useful. So you have to sort through the noise to find the signal. But those 3 things: unique, accurate, important. Those are at a very high level. Those are things I like to do. And yeah.
Yes, and if we go to the one source of data is about social media, and maybe Neil, to what extent do social media platforms reduce public trust in AI?
Thank you, Florence. I mean, this is a huge topic and one that is being discussed politically, and I spoke to it earlier. I think the challenge has been historically there's been a presentation to the public that social media companies could use AI algorithms to clean up disinformation and misinformation online. And yet we know that not to be the case. In fact, we know that once misinformation hits online, this is especially problematic with COVID, it's actually too late. And so what's really happening is that humans, with all their failures and all their limitations, are really the people on the front lines trying to correct misinformation. So I think there's an obligation actually for social media companies to be a little more humble about the limits of artificial intelligence in cleaning up the state of the web. And, you know, to be fair, I mean, Rook, a lot of people, visionaries about the internet, were wrong. You know, Tim Berners-Lee felt that we'd have an elegant semantic system on the web. Mark Zuckerberg thought that we'd have a clean community portal on the web. Jimmy Wales, Wikipedia, same thing, right? But no, the internet has actually evolved to become quite the opposite, a really clunky mess of increasingly dysfunctional litter. And that actually is incredibly exciting, I think, for you know, the nerds among us who are trying to find signal in that noise. But it is problematic when you have certain companies that will suggest that the so-called AI algorithms, which are really quite primitive, are going to clean up that information. We're just not there yet.
Thank you so much.
Yeah, let me disagree a bit with Neil in the sense that everybody's saying these days, oh, big tech is responsible of the mess in disinformation. And partly that's true, right? I give you some sort of part of, I think that is true, but I think that politicians and actually mainstream media are oftentimes to be blamed about starting to spread this misinformation, right? So I think it's a little bit biased to say, oh no, it's the platforms that have to be regulated. I agree that the platforms have to be regulated, but at the same time, it's very annoying or upsetting as a citizen to see that the misinformation comes from other sources that are lying openly to the public, right? And they also need to be regulated, right? In that sense. This is my view as a citizen, as they say.
And to finish, Arthur, do you have a point of view, an opinion about this specific question about social media and the trust in AI?
Oh, I feel like, yeah, I heard both very good sides, because as they were talking, I almost was like, you know, you need to define information, right? Like if the president says something, is this information? President of US, obviously, I'm referring to. So you're like, is this information? And it's not clear. So no, I don't want to take any more time on this topic. I think we could all go endlessly on about it.
Yeah. Thank you so much, Neil, Miguel, and Arthur for your time. And now I will give the floor to Andreas, who will do a summary and closing remarks.
Thanks a lot, Florence, and to the panelists for this discussion, sharing your thoughts and actually having some fun there as well. For me, it was fascinating to hear Mohanty speak about the commonality of skeleton trains and tax policies, meaning how Bob learned to walk with the help of an entire community. And maybe Bob ran to catch eventually a train from Flatland that was not delayed. Miguel's speech was very insightful regarding the trends and thoughts and the application of AI in finance. Then Neil taught us about data humility and how to apply the concept, humility being the essence both for humans and maybe systems, and that we need to continue or maybe start again to take privacy very importantly. And Apuri gave us an insightful view about AI and AI asset management, starting with his very own experience, how to master a challenge, and maybe also the battle between interesting and relevant. So thanks a lot for this discussion. Jay, one question I have to you. Do you, before I hand over, do you think machines can think? I mean, it's a yes or no question. What's your answer?
Yes, they can think, but they can't think to think yet.
Over to you, Jay. Thank you.
No, thank you very much. This was a very, very interesting discussion, especially for me. As a wealth manager, I only have two jobs, two very simple, distinctive jobs to do. One is understand the client, and the second is to manage his money. Now, when it comes to understanding the client, this is a very archaic way of doing it. The managers have a client profile sheet, which they ask the client to fill in, which has the client's name, his passport, and then they ask a few questions, very basic questions on his or her experience in asset management. So any experience in equities, in bonds, and then there were kind of returns they would like to see or they cannot absorb or take. So can you take a risk of 5% or 10% or 20%? Then that form is filled up, signed, and put in the drawer. Very little real analysis done. No one actually checks whether this person is male or female, or young or old, or from which society, which cultural background, how they answering, what is the real information that's in that data, and how do we interpret it? So actually the knowledge of knowing the client is all left to the human being. And so if you have an organization with 100 bankers, they all have different profiles for their clients based on who they are themselves as bankers. In that sense, it gets very complicated. And this is where AI would be very, very helpful going forward. Now, the second part of this is managing the client's assets. And this is where I was very fascinated and loved what Ruben, Miguel, and Neil has talked about, because the fact is it's all about data. It's all about taking the data, the integrity of that data, and using it. Now, Neil talks about known and unknowns, and that's a big problem for us in wealth management. Is the data is the past. It's not the future. We try to use this data to see whether it has any relevance to the future. Now, obviously, this will depend on many things, but pattern recognition is certainly one of them, but pattern will continue working until it doesn't work anymore, until it's not a pattern anymore. Brooke talked about the fact that the data is not just about the data, it's also about the people using the data, and therefore the team is very critical in that. So there's a lot of work that still needs to be done. But what it makes me feel very comfortable about it, in fact, is that AI is here to stay. It's something that I think will be used much, much more. And I just wanted to read you something from Society 5.0. I don't know if you've seen this, but this is a paper from Japan, where they say that they are we aim at creating a society where we can resolve various social challenges by incorporating the innovations of the fourth industrial revolution, IoT, big data, artificial intelligence, robot, and the sharing economy into every industry and social life. This is Society 5.0, a super smart society. Japan will take the lead and realize it ahead of the rest of the world. Big data collected by IoT will be converted into a new type of intelligence by AI and will reach every corner of society. This is where Japan is going. As we move into Society 5.0, all people's life will become more comfortable and sustainable as people are provided with only the products and services in the amounts and at the time needed. We're talking about a very, very efficient society. And we must not let that happen only in Japan. This must happen in every part of the world, in every industry, in every sector, and certainly ours. So the idea is that we need to get together, all of us, and work on this. I think putting great minds together is very important. So there's this hashtag that has been put out, which is hashtag AI Finance. I encourage us to all work on with this, put on our ideas, our solutions. What Sharda is doing is phenomenal with AI Crowd, is putting a community of people together in AI to find solutions that we have. So I think we should be using a lot of what he's doing too, coming up with our issues and asking the community at large to solve them for us. So I think this has been very, very helpful for me. And thank you, Capico, and thank you, Andrea and Florence, for this.
Thank you very much, Jay. Thank you, everybody. And I wish you a great evening, noon, morning. I don't know. We have different time zones. Thank you very much for your participation. Much appreciated.
All right, guys. Thank you.
All the best.
Bye.